And now let's see how to start with an FEA analysis. What would be the first step to start an FEA analysis? The first step is definitely choosing the right element. So how do you choose an element? It is based on the order or the shape function. Is the shape function linear or quadratic or cubic or higher order? The interpolation functions for displacements. So it could be called the hat function, shape function, or interpolation function. All this function does is interpolate what is happening between those points. So in a linear, if there is a linear interpolation function, so it will interpolate what is happening between two nodes. And if it's quadratic, it would have three nodes. So three and what is happening within those three nodes. So this is slightly better. And if you want even more, go for cubic. So when you go for a cubic interpolation function, so that interpolates well. So hope you know about interpolation and extrapolation. So here we will be interested only in interpolation. Extrapolation is something beyond this range, whereas here we want to know what is happening within this range. So it is either you can add the number of elements or you can increase the order. Like we saw in the previous one, where there were just two elements for the quadratic or four elements with linear. Which was better? Two elements with quadratic was better than four elements. So the order is also important, apart from the number of elements, whether it is coarse, fine, too fine, ultra fine. It's the number of elements. Apart from number of elements, shape functions also matter. So which shape function would you consider? So now here in continuum elements, the degrees of freedom are called displacement components. So are the displacements or degrees of freedom translational degrees of freedom or rotational degrees of freedom? What are the rotational degrees of freedom? Yeah, roll, pitch. And similarly, translation is along x, y, z. So now an approximation for the displacement function within each element, either you can have it as linear or quadratic. So if you have to understand what is happening around the board or around a circle, the board has a cylindrical surface or a hole in a plate. So that is what your area of interest might be, because the stresses would be more surrounding the bolt hole or any hole. So it's better to focus on that region and take up a quadratic variation so that you get all the displacements. You can capture more number of displacements, more the number of nodes, you can capture more displacements. So Here, what they have used is they have used 8-noded isoparametric. Iso is same. So what is same here? Isoparametric quadratic element with 2 cross 2 Gauss integration points. So what is the difference between interpolation and integration? So what does integration mean? And what does interpolation mean? So here what you see is the good practice and the bad practice. Towards the left, what you see, and towards the right, what do you see? So just look at this. What you see is a sharp edge here. What is actually a hole, a circular hole. But since it's a linear element, there are only 2 nodes here. You're approximating a circle to a hexagon or octagon. So 1, 2, so it's an octagon. So whereas here it is a circle that is captured well. So for curved boundaries, the good practice would be to go for quadratic or higher order elements. So now here what you see is that, so here when you look at this picture, so this talks about compatibility. What is the meaning of compatibility? So what comes to your mind when you think of compatibility? Or what is incompatible rather? Which one is desired? Compatibility or compatibility? Compatibility is desired. So it's the like-minded people who join together. If the ideas or opinions are different, then they always get into a tough argument, heated argument. So that is what happens with the elements. The linear elements, they want to stay together. Together, they gel well. But when it comes to quadratic elements, they always have a struggle. So here, if we'll just consider these 2 elements, they have a good compatibility. Whereas here, even though there are 3 nodes here and there are 3 nodes here, still there is some incompatibility because the quadratic element is just one element and has 3 nodes, whereas here you have 2 linear elements and these elements have just 2 nodes. So here, this might look like, okay, you can just combine them. No, they are not compatible. They never gel well because this is of lower order and this is of higher order. There is always some discrimination. So the good practice would be, if you look at here, this element has mid nodes and this element also has mid nodes. And similarly, this element also has mid nodes. So they don't have a problem with sharing the common nodes here, here, here. So these are the 3 locations where you have shared nodes. Since all the elements are quadratic elements, they are of the same order, so they gel well, and it is a good practice to keep them together. So now you have 2 options. Suppose you can use just a 4-node element, or linear is just 4 nodes. Whereas quadratic, you get 8 nodes. It's the double of it. So which one is greater? It's quadratic, which is always the higher. So for this particular problem, what kind of problem is it? Oh, okay, it's a circular hole geometry. So circular hole geometry, definitely this quadratic is good because it captures the profiles very well, and it is definitely better than linear elements. So now what you see is this we already looked into, assuming that the first step for any FEA analysis would be to choose the element which is linear or quadratic or cubic or whatever. So here what we see is we learned that the shape function or the hat function or the interpolation function, they define or they describe the behavior of displacements when it comes to structural analysis.